The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone, and welcome to the H-Prize Safety Guidance webinar. My name is Chris Worth, and I'm the organizer for this meeting. We'll begin shortly, but first I have a few housekeeping items to tell you about. Today's webinar is being recorded, and the recording, along with the slides, will be posted to the H-Prize website in about 10 days. We will send out an email to attendees once those are posted to the site. All attendees will be on mute throughout the webinar, so please submit your questions via the questions box you should see on your webinar panel. We will cover those questions during the Q&A at the end of the presentation. Please note that we will be focusing on questions pertaining to safety in this webinar. With that, I would like to introduce our DOE host, Katie Randolph, joining us from the Department of Energy Golden Field Office in Golden, Colorado. Katie is a technology manager in the Fuel Cell Technologies office. Good morning, Katie.
Good morning, Chris. Thank you very much for organizing the webinar, and thank you to all our attendees for calling in. As Chris mentioned, this is going to focus on the hydrogen safety planning aspects for the Hydrogen H2 Refuel H-Prize. And just quickly, I'm assuming most of you calling in are very familiar with the H2 Refuel competition, but just to give a quick update or a quick summary of the prize. It is the 2014-26 H-Prize competition challenging America's innovators to deploy on-site hydrogen generation systems using electricity or natural gas to fuel hydrogen vehicles that can be used in homes, community centers, retail sites, or similar locations. It's really a way to supplement the infrastructure that's being put in place as the hydrogen fuel cell electric vehicles are being rolled out. So at this time, I'd like to turn it over to Nick Barillo and Don Frickin from our hydrogen safety panel to really go into the details of this very important aspect of the competition around the safety planning and guidelines. So Nick, I'll turn it over to you at this time, and thank you both for presenting to interested and potential contestants of the H2 Refuel H-Prize.
Thanks, and good day to everyone. My name is Nick Barillo. I am the project manager for the Hydrogen Safety Panel. I am also a fire protection engineer of about 30 years. And what we want to do today is really share with you a little bit about safety planning for the competition, go into some details and some resources and that sort of thing. Don Frickin from the Hydrogen Safety Panel, as mentioned, is also joining on the call, and he will likely be chiming in at times and giving some perspective and helping answer some of the questions that you may have at the end of the presentation. So to get started, this information is directly from the Hydrogen Prize webpage. The key here is that safe practices are essential for establishing confidence, public confidence, and reducing barriers. It's really important that safety be integrated into this activity. There are ramifications to the competition and to those competing if safety isn't given adequate consideration and something happens. So as part of the design submission, as stated on the website, contestants must include a safety plan, a hazards analysis, and really need to have information provided from their local code officials, whether it be fire, building, zoning, to ensure that the necessary safety features and considerations have been integrated into the competition. So we'll now jump into some slides that go into a little bit more detail about safety planning and that sort of thing. A little bit of background before we go into that. PNL has a core capability in hydrogen safety to meet the DOE Fuel Cell Technologies Office goals and needs. The capability is implemented through the resources below, of which one is the Hydrogen Safety Panel, and we'll go into a little bit more detail on that. Some safety knowledge tools for helping those that are in the midst of designing or deploying some of these systems, and first responder training resources. We'll talk about those at the end of the presentation. So covering the Hydrogen Safety Panel, the panel is a team of highly experienced individuals created to address concerns about hydrogen as a safe and sustainable energy carrier. And really, we function in a variety of areas, and our objectives are identifying and addressing safety-related technical gaps, making sure relevant issues and best practices that affect safe operation are brought to design, construction, and operation personnel, and then work with various projects and those involved in deployment activities to make sure that they understand the issues and that they make safety a priority for that activity as well. The panel does contributes to its objectives by participating in safety reviews. That includes safety plans as well as other design reviews. Sharing safety knowledge, presenting and recognizing safety as a priority, participating in incident investigations, and really working with stakeholders and other interested parties to become more familiar with issues and safety resources and safety practices. Some accomplishments: the panel has been around since 2003, established early in the DOE process of the hydrogen projects. Since 2003, we've been involved in over 270 projects covering 410 activities. You can see in bullet 1 there a number of different types of fuel cell and related hydrogen projects that the panel has been involved in. We've also been involved in providing, identifying gaps and providing white papers on those gaps, supporting some of the codes and standards development and that sort of thing. The panel member list is there on the right in the table, and you can see we're made up of a variety of folks from different industry, national labs, other government agencies, private consultants. Over 400 years of experience resides within this group of experts, and it's a unique opportunity to tap this group to get some input on safety and safety planning. So over the years, since 2003, we've been involved in a lot of R&D projects as well as demonstration projects, and we've learned a number of things from that. Some of these learnings are from the activities that took place under some of the ARA projects, but they really are relevant even to today and to the H-Prize competition. And I'm going to jump through these real quick. Project integration, it's really important that all those involved in project planning and the hydrogen project are involved in the safety planning activities. So this could mean the designers, it could mean those performing construction, operations, maintenance. It's really important that all understand the safety aspects and the necessary safety activities to ensure that we don't end up in a situation where we have an incident or someone gets hurt or some equipment gets lost. Hazard analysis. A vulnerability analysis really needs to comprehensively consider all potential incident scenarios and what the mitigating features are for those scenarios. Requirements. What we found in some of the projects is that some of the practices that were done in R&D phases don't necessarily translate well to deployment, and so some of the safety issues, code issues, and those sort of things really need to be considered. And so when you're involved in this project and you're putting it together, it's important while you're doing part of this is R&D. It's really also meant to be ultimately a long-term thing that can result in commercialization. And so considering the requirements and integrating those into your activities for the long-term benefit would be very beneficial. Certification has also been an issue. Currently, the codes and standards look for listed and approved equipment. Listed equipment is typically listed by a third party, such as UL or other Factory Mutual or other similar agencies. Isn't a lot of equipment available that's currently listed. When that happens, it puts the responsibility back on your local code official to make approvals, and so it's really important to understand that and to be working with them to understand what you're doing and how the features in the equipment are safe and could be approved. So the need for safety planning, and this is really the important part we're jumping into here. And I want to stress, while the competition, those providing or inputting into the competition are required to have a safety plan, it's not just about writing a document. And we've seen a lot in the panel over the years, and sometimes the effort is just to get a piece of paper put out so that they can, check a checkbox. And that's the paper is a necessary part, but the real goal here is to integrate safety planning across the entire activity, not just for what's written on paper, but the practices and the thoughts of what happens beginning, midpoint, endpoint, use, maintenance, all those. It's really important to consider safety. So it's essential to protect people from injury, and it's also necessary to minimize damage to facilities. primary goals of safety planning: identify the hazards, evaluate the risks by considering likelihood, likelihood and the severity consequence of an incident, and then to minimize the risks associated with the project to acceptable levels. Various hazard analysis and risk assessment techniques are typically used to do that. And it really is that safety planning should be an integral part of the design and operations and not an afterthought or a final hurdle to be overcome before a system can become operational. So we put a lot of these points down as the panel, the hydrogen safety panel, will be reviewing the submittals, and we're looking to see that safety isn't just an afterthought or isn't just a checkbox, that it really is given thought and consideration for how to be implemented across. Some guidance for effective safety plans. The project safety planning process is really meant to, again, help identify and avoid hydrogen-related incidents, and then to generate a good safety plan. The key here is that a safety plan should use a graded approach based on the level of risk and complexity. And it really needs to cover all the experimental and operational work. You've probably heard me say that a few times now, with particular emphasis on the aspects involving hydrogen and hazardous materials. The safety planning guidance is available off the HPRI's website. It has been, the original guidance, the safety planning guidance, dates back to 2007, I believe, and was updated in 2010, and then has been subsequently updated for this activity to be very specific for this activity. Some of the topics that are covered by that safety planning guidance are identified there on the left, and at the center of all that is identification of safety vulnerabilities. Really, the key critical point is to understand what the hazards and the risks are and to mitigate those accordingly. So focusing on the hazards, in general, a good safety plan identifies primary failure modes and then secondary failure modes that may come as a result of other failures. An attempt for effective safety planning, an attempt is made to identify all conceivable failures, from catastrophic failures to benign collateral failures. Identification discussion of perceived benign failures may lead to identification of more serious potential failures. So in that hazard analysis process, it's really important whether you use HAZOP or something more like a what if. It's really important to look at all the potential conditions, and then as you move through that process, eliminate those that are of lesser risk overall. A little bit of information. Two questions that really need to be addressed in the ISV are what hazard associated with the project is most likely to occur, and then what's the hazard that has the greatest potential for a consequence, or the worst consequence, I should say. In providing a hazard analysis and discussion of that in the safety plan, we really want some information, like what method was used for the identification of safety vulnerabilities, who led and stewarded the process, what the significant events were, and what the safety critical equipment is, vulnerabilities and risks are identified adequately, that sort of thing. And this tends to be a really big point of comments that we've made to projects, and probably one of the more leading weaknesses in safety plans has been really in this area, that it wasn't clear that all the hazards and the risks were identified and mitigated properly. There was either inadequate discussion in the safety plan, or it seemed like the safety plan didn't address all the issues. And so this is an area that you really need to focus on, and it's really, again, the center of the safety plan. So I'm going to jump a little bit into codes and standards. There's a number of codes and standards that would be most applicable to this project, certainly NFPA 2, and I've thrown the 2016 sticker on the right because the new version of NFPA 2 is due out on August 28th. If at all possible, it would be good to use that edition, as it's greatly improved over the 2011 edition, and again, should be readily available here shortly. Some other codes: NFPA 70, the ASME B31.3 or 31.12 would be helpful, leaning more towards 31.12 for some of this activity. The boiler and pressure vessel code, and J2719 for fuel quality. Some others that may apply depending on the type of equipment that you end up providing, J2601 and 26012, as well as the ISO standard. Additional codes and standards could apply depending on what you're doing and where you're doing it at. The key here is that really your location is going to have some impact on what codes and standards are also required locally. And so some discussion in the safety plan as to what those codes and standards are that you're following and are required to follow to do your local requirements would be good to have in your safety plan. Submissions that deviate from base codes and standards need to provide detailed information on what is different and how equivalent safety is provided. The codes themselves, for the most part, NFPA 2, for example, has standard language that there are acceptable alternate means and methods if those alternate means and methods can be demonstrated as safe and are approved by the local authority having jurisdiction. So it would be important to understand where you're deviating off the codes and the requirements, and that you have a good technical basis for that, and that you've ran that technical basis back through whatever code official you have and gotten their consent on that as well. So some relevant questions. Do you know who your local code official or AHJ is? And to what degree have they been involved in the design and installation of the equipment for the project? So in this case, for the submittal, it would be more the design than the installation. You may be discussing how they'll be involved in the installation as well, though. Was there any special permitting or certification that either was or is required? Has a third party or certification of any of the components, subsystems, products, et cetera, been considered and performed? Some additional documentation is required in order for the hydrogen safety panel to really understand what it is you're doing and have a good feel for the safety is provided here. Things like process flow diagrams, a preliminary design or functional description for components in the systems. We already talked about the codes and standards, compliance discussion. I'll take this one step further though and say compliance discussion is a little more than just saying, we'll apply this. It's really saying, what are the specific codes and how you intend to meet those, or what you intend to do where you can't meet those and that sort of thing. Depending on what phase you are in designs and what we see for the documentation, codes and standards compliance can be a little more detailed and to be beneficial for everyone involved. Most designs at a larger level go through some of this to understand, whether it be NFPA 70, some of the other standards, the boiler and pressure, the ASME standards, what are the requirements and how have we met those? Layout of the system and considering things like required separation distances, vent system considerations, electrical classification, ignition source control, ventilation requirements for enclosed spaces, that sort of thing. All that would be very beneficial and really is necessary for some of the safety planning documentation.
Well, while you're here, Nick, it might be a
Yes.
really good idea to talk about whether or not confidential or proprietary information can or should be included in this set of documents.
Thanks, Don. That's a really great point. So if at all possible, we would rather not review anything that's confidential. Obviously, it puts a burden on the entire process to make sure there's some NDA agreements set up. If it's necessary for purpose of providing documentation, ensuring that we all understand the safety planning and that sort of thing, I would suggest that it be discussed with the Golden Office, and we work through some sort of an agreement on how to do that. The way the panel is set up, the panel is under an NDA as part of contract to the Pacific Northwest National Laboratory. We would need to know if there is information that is confidential in nature, or very business sensitive, and so that we can alert those that are doing the review that they can't share that information in any way, shape, or form. And so, let's, if that need arises, then let's do that. If all possible, let's stay away from that kind of information in the safety planning documentation. Anything else on that, Don?
No, I think you covered it well.
Okay, I'm going to jump into safety resources now. These are resources that could be helping you with safety planning and some of the safety plan writing activities. I'll start out by talking about the Hydrogen Tools portal. This is a new website that has been brought online just this summer, and really it was meant to organize a lot of different tools into one location and make those tools much more interactive and allow much better tapping of those tools to help you in safety and safety planning. So it's a centralized location. It's focused content. So we really considered what the user groups would be for this, this kind of content, and that includes things like code officials, project proponents will be yourself, first responders, could be research and developers, operations and maintenance folks, that sort of thing. And so the content has been tagged accordingly, and workspaces have been set up to help those specific groups navigate and communicate and do that sort of thing. It's set up with a responsive design, so the site is very usable on the desktop all the way down to the phone. And we've really been working to establish some trusted communities. So those have all been set up. They haven't been very populated yet because we're just getting off the ground. But what it would allow is some of these user groups to ask questions, and hopefully those that have similar experience could share some answers and really help where people may not have a lot of experience. So some of the tools and resources that are available in the portal include the best practices site. This could be very beneficial for those of you that are new to hydrogen and fuel cells and some of the issues and hazards. You can see some of the topics on the left that are covered by the site, the best practices manual. And I'm going to jump in and give you an example. So some of the information would be discussing some of the gaseous hydrogen properties. So for those of you that, if this is all old stuff, just bear with me for a second, but hydrogen has a flammable range of 4 to 75%. It's very light, will typically rise 14 times lighter than air. It diffuses through material not normally considered porous. So the molecule is so small that it can really move through different types of material, and we'll talk a little bit about compatibility later on. In a stoichiometric concentration, it requires only a very small amount of energy for ignition. 0.02 millijoules, there you see, is extremely small. Burns with a pale, almost invisible flame. There are some resources available on the portal that can show you some videos of that sort of thing and get a better feel for how it looks daytime and nighttime. And hydrogen certainly can embrittle some metals. You see in the tables on the right comparing the ignition energy versus some other more common fuels, as well as the gas to air volume ratio for flammable range. One important point on the top bar chart there is that while hydrogen has a very large range, 4 to 75%, typically in the 4 to 6 to 4 to 8% range, it doesn't burn very well, and so really it really doesn't start becoming a significant issue till you get in the 6 to 8% range and move up from there. So the lower number is actually higher in some respects. The danger point is a little higher than some of the other fuels. Hydrogen properties, a comparison to some of the other fuels. Probably some of the best here is the odor. It's odorless, whereas natural gas you're going to smell it, and obviously you do with gasoline as well. Energy by weight is very high, but energy by volume is much less. So you can see some of the differences compared to gasoline. One of the, for those of you new, one of the advantages of hydrogen in a vehicle is while it has to be stored at high pressure, if there is a leak or an event in which a relief device opens, the gas moves quickly away, where gasoline would typically pull and be there should an ignition source come along to cause a problem. So another resource that's available is the Hydrogen Tools Lessons Learned database. This has about 216 records in it. Some of the record information is described there on the left. I would point out that the information in the database is given an anonymity, so what you get is information that it's not attributable to any company or specific event as far as giving details that would give away where that is and when it happened. So I really want to focus 2 points on this lessons learned. One is that it's a great resource for understanding what has happened. Go out there, look around. You'll probably find a number of issues that could occur in a situation that you may be designing for. The other point I want to make is that if you do have an incident during execution of the project, we would really like to know about it. You can submit it directly through the portal. Again, the information is kept anonymous, so you won't be singled out in any way. You'll provide your contact information, but that is only for us to work the lessons learned record with you to make sure we get it correct and provide the right lessons learned language for helping others in the future. So another resource available is the technical compatibility material resource. That this is really looking at metals and their compatibility with hydrogen. Really recommend you understand the information here, because the materials you may use could have some compatibility issues and could result in embrittlement. I'll give a quick example. There was an incident that occurred from a relief device that ended up using the improper material selection, and it ended up failing. There was a release of hydrogen. There was an ignition of hydrogen, and so making sure that you have the right materials that are compatible with hydrogen are really crucial for keeping safety as a primary focus. So some other resources, hydrogen safety training for researchers. So for those of you that might be new, this is a very good resource, giving some of the basics of hydrogen, how to handle hydrogen properly, how to deal with pressure systems, cryogenic systems, overview of emergency response considerations, that sort of thing. It could be about a 4-hour course if you take your time going through it. Really good resource, and the link there is at the bottom if you are interested in taking it. It's also referenced off the Hydrogen Tools portal, so you can click on that to get there as well. I want to discuss a few things in working with first responders. So for those of you that are able to get approved to move forward, it's important that first responders be brought into consideration to understand the hazards that you're working with and being prepared to respond should something occur. So we have a variety of resources, and so I would encourage you to work with them to first let them know what's going on and what the hazards and what the quantities of materials you're using, that sort of thing. And then the other thing would be to assist them with training so that they could be prepared. And I'm going to talk about a few of the training tools that are available. It's also could be beneficial to encourage them to have a thermal imaging camera available, on their vehicles if they don't already. Some fire departments in larger urban areas already have those. Smaller rural departments typically don't. So that could be very helpful for the process as well. So we have a number of tools that are available for first responder training. This really includes.
Nick, I'm going to just interrupt real quickly. Could you maybe move a little bit closer to your microphone? We're having some comments that it's so difficult to hear.
Okay, I'm sorry. Is that any better?
That's better. Thank you.
Okay, sorry about that. Three of the tools that we currently have available are an online awareness level training. That's a course that you could go through, or a first responder could go through at their own leisure and learn about some of the hazards and some of the things that need to be looked out for. A classroom and hands-on operations level training, that probably won't come into play for this activity. We occasionally provide that. The last set we had were in Washington State. We're currently in discussion about having some of those trainings in the Northeast next year. And then a national training resource, and this is really a series of slides with instructor notes to help trainers perform their own training. Could be valuable if you wanted to actually give a briefing to first responders. You could use that resource to put that briefing together and have most of the information right at your fingertips to do that. So this is all being done in collaboration with the organizations listed there at the bottom. And again, the note in green, important to highlight that it's critical to have the first responders involved to make sure that we have a safe transition. The online training, here's just an overview screen. We've had over 32,000 visits to this since 2007. Still a very popular resource, and Again, if you went at a very speedy clip, you could probably get through it in an hour, but it probably takes 2 to 3 to get more of a leisurely pace of getting to know what's on there, and could be taken in multiple sessions. The National First Responder Training Resource, a few slides here of what it looks like. So the slides on the left it's 130 slides in the slide deck that cover a lot of detail, from general safety all the way through the vehicles and what's on the vehicles and what to look for, and then how to respond. We give you a guide in a Word file as a part of that download that provides some suggestions for how to use the slides. Again, you could use them any way you want, as far as if you wanted to use 10 of them, 50 of them, whatever you would like to do. It's adaptable to whatever you need, but we give you some suggestions in the Word file. Since 2014, we've had almost 280 downloads. We're now over 280, actually. 6 continents, 50 states, and it's been translated into Japanese. So it's been a pretty successful resource. I've had some good feedback from it. I think what's interesting about this map that I like to tell people is, while California has had a lot of fuel cell activity already, it's impressive how folks in the Northeast have been seeing this resource and going and downloading it. So some final thoughts before we jump into questions and answers is, safety panel serves as a contestant's continuous and priority attention to safety, helping you guys focus on that. Learnings from individual projects benefit the broader safety knowledge. And so what you learn, if you're willing to share that, can really be beneficial to others, just like that current lessons learned site is there, and you get to learn from what other people have learned. So we're going to ask you to share your lessons learned and incidents and near misses and other things. And then contestants may request assistance from or provide input to the safety review team and the safety panel on any safety-related topic. So I do have my contact information at the end. If you want to get a hold of the panel, you can do that through me. And that'll bring us around to questions and answers. So at this point, I'll open it up, and I think Don and I will try to answer some of those questions to the best of our ability.
All right. Thank you very much, Nick. Very nice presentation. We do have some questions that have come in during your talk, so I'll just read you the first one. It would be terrific if you would speak to past lessons learned, such as the AC Transit hydrogen issue in Emeryville, California.
So I don't want to give acclamation, or I don't want to push and point at anybody at this point, but certainly there are lessons learned from the AC Transit. Was a compatibility material incident, and as well as a managing first response, and there's actually a report out on the internet on that could be downloaded to get more information on that. The incidents database, I just would refer back to the incidents database, the lessons learned database, because it really does, the focus of that database really is lessons learned. What did we learn? And it can be searched down to some very good detail of what you're trying to find, what type of incident it is, either by title or by location and that sort of thing. So and we're available if there's some discussion that needs to happen on some other specific incidents or learnings or how those could be applied. We'd certainly be willing to help you out with that as well.
Good response.
Okay, another question. Are there any specific white papers that the Hydrogen Safety Panel has published that are relevant, and will these white papers be part of the safety guidelines document?
So the panel has published a number of white papers. A few of those are on the portal, are available on the Hydrogen Tools portal, and could be downloaded. Looking to relevancy, it would really depend on the specific design. I think the most recent white paper that was done by the panel is a paper on safety and hydrogen equipment enclosures. That information actually helps support changes to NFPA2, which are going to be available in the 2016 version. So the white paper is available if you'd like to look at it. The code changes are available, and those are in section 7.123, I think it is, of the NFPA2 in the version that's due out at the end of this month. those that might be beneficial depending on the kind of final configuration. If you're using an ISO container, that sort of thing, that certainly could be impactful. You could go out and look and see if any of the other white papers might be beneficial to what you're doing. They're not going to be, certainly the use of those white papers is not required by the safety planning guidance document.
I would like to say that most of the white papers are dealing with information that we need to have that we don't have now. So they tend to ask more questions than provide answers. As Nick pointed out, the specific issue on enclosures is mostly answered by the revision to NFPA2. So NFPA2 would be a better resource than that particular white paper, I think, for purposes for this project.
Just one comment. Can you go back? There's a request to keep your contact information on the screen while we go through these Q&As. Thank you. Okay, so is there consideration for developing standards to advance safe deployment of hydrogen residential refueling? This will help ease the burden on the authorities having jurisdiction.
Yeah, that's a really good question. There are some requirements out there right now that are applicable through the I-Series codes. The International Residential Code applies and brings in some requirements to this. They're not extensive. I had a similar question asked to me a couple years back at an NFPA conference, and someone had a fuel cell being installed in a pit in a backyard of someone's house, and the requirements really aren't there yet in a very good way for residential applications, apart from the International Residential Code, and that really doesn't cover it very deeply. So, moving forward, is it a good thing to be focused on? I think what we'll end up doing is we'll seeing NFPA2 used, and some of the IFC and some of the other codes, International Fire Code, some of the others, International Fuel Gas Code, maybe being used for application to residential. I think there's going to need to be, as that's done, the issues and the gaps that come forth, like out of activities like this, would really be beneficial to know what those gaps and issues are, so that we could push that back to the folks on the code committees to consider that further. Don, I don't know if you have any other thoughts on that.
No, I think you're absolutely correct. The development of these standards and requirements are in the future. They're not now.
Okay, we have another question, and I'll probably answer this one. How important is the safety plan in the finalist selection process? It is extremely important for the finalist selection process. You won't be considered further if your safety plan isn't up to par in terms of the initial review. So it's one of the minimum requirements, and so we encourage you to continue to ask questions right now for clarification, and to continue to submit questions to our HPRISE mailbox on this subject, so that we can address questions related to this. So it's extremely important for the process.
I'd like to add that we don't want anybody to build anything unless there's some assurance that it will be safe.
Okay. Another question is, what is the target page count for the safety plan? I don't believe there's a target. I'm assuming it's based on the system design, but I can let you speak to that next.
Yeah, that's one of those where it's like it's not about weight or size. It's really about content, and making sure that for some projects we've seen that a small safety plan can cover it extremely well. For more complex projects, though, it really does require thoughtful and thorough consideration of the issues, and so. It's not about, we're not looking for a certain number of pages. The guidance document really should help you understand the topical areas that we're really looking strongly at. Though it should be said that even those topical areas, there could be some things outside those topical areas that you might need to consider as well. It's really helping those that are performing the review to understand that safety has been thoughtfully considered and applied, that the risks are understood. The hazards are understood and mitigated accordingly.
Or eliminated.
Or eliminated, that's right. Thanks, Don. Better yet.
Better yet, that's right. Okay, another question. Is there a reference or compiled list of lessons learned, such as a one-stop shop for past safety concerns?
I think that the lessons learned site, maybe I'm missing the question here, but I think the lessons learned website has a lot of that information in it. This presentation also discussed some of the things that we have learned from reviewing safety plans, with some of those, probably some of the more significant weaknesses of the safety plans have been. So I think if you use those, and certainly if you have any additional questions as you're going through your safety planning process, we'd be happy to to deal with those specific questions as we go. We could do it now, or you could send an email or give us a call, that sort of thing.
One of the appendices to the safety planning guidance document is a checklist, and that checklist of things to consider was derived in part from past problems. So using that checklist will give you some clues about some of the problems that we've seen.
Okay. Another question, do you have a preference for organizing the safety plan for systems and subsystems?
Don, I'll let you jump on that one.
Anything that is written that we can understand is fine.
Okay. Do you have an example safety plan for residential or commercial that would be best to use as a base case for consideration?
So that's another one of those really good questions that there's not a real good answer to. We've been part of we have had in the past a number of good example safety plans that have been available, but those were really more geared towards the R&D phase of things than they were towards demonstration activities. So at this point, we don't have anything that we can readily give out, and if we did from some of the other projects, it would only be, there would probably be some gaps because of the focus of this activity. So if you can imagine going through the process to get a good example safety plan, not only does the safety plan have to be good, but we have to go through a process of getting folks' permission to use that and make it more publicly available, and that can be a little difficult at times too. So unfortunately, there's nothing that we can really provide. I don't know, Don, if you could think of anything that might be a little more helpful in that area. Maybe I'm missing something, but I'm not sure that we have anything directly that would be applicable.
Yeah, as Nick has said a few times, we're really looking for original thought. If we gave you some examples, in fact, some people have submitted some plans to the safety panel that were almost word-for-word copies of the examples. I'm afraid that that would be a problem for us. So we would really appreciate a planning document that shows original thought and consideration of the safety issues.
Yeah, let me speak one more. That's a good point, Don. One more to that point is we actually had a safety plan submitted earlier this year, in which, on first glance, it looked very thorough and looked really good. But as we dug into it a little bit further, there was a lot of information that was paraphrased out of our safety guidance document, but was also paraphrased out of some of the OSHA requirements. And so, it's good that somebody understands all those requirements, but really understanding how the project went about to apply those requirements is more important than just putting a canned statement about something that OSHA may say, make sure you consider this or that. So that good point, Don. Thanks for sharing on that.
One last administrative question we got was, will the slides and recording be available? We will make the slides and recording available. It's usually available within 10 days of the webinar, and if you registered for the webinar, you'll get a notification that they're posted. So let me see, we might have just got one more question in. So this is an interesting one. What scares you most about hydrogen?
Wow, there's an open-ended question, right?
Yeah.
So I don't know that I would use the word fear or scared as being a good descriptor for hydrogen. Hydrogen is a hazardous material, and like all hazardous materials, it has to be thoughtfully considered, and you have to understand its properties, you have to understand its potentials, and you have to provide controls and mitigation accordingly. And so to the point of what are the things that could make hydrogen a little different, obviously its wide flammability range, its buoyancy. In many of the applications with fuel cells, it needs to be handled under higher pressures, which means you typically have higher stored energy, which is always, whether it's hydrogen, oxygen, nitrogen, whatever it might be, stored energy always has its own set of issues and should be planned for accordingly. So I think some of those, Don, you feel free to jump in and add anything else you might want to add to that.
Yeah, I would say that hydrogen doesn't scare me at all. It's the people that are using it that scare me, especially if they don't understand the safety issues.
Well, thank you both. Yeah, it sounds like, as always, with any material that you're handling, education is key and understanding what you're dealing with for the safety aspects. So.
Yeah, absolutely. That's the key, and that's why, if I can reemphasize, why all these resources have been made available. They're really here to help you. The best practices site, if you're new to hydrogen, the best practices site could be extremely valuable to you. Certainly the lessons learned, some of the other resources that are available on the Hydrogen Tools portal, all that's there to help you learn. And we're here if you have questions to let us know if there's something we can answer for you and make sure that we're all heading down the right road. When handled safely, hydrogen is going to be a very transformative fuel for our future and for future generations.
Well, thank you again. Before we wrap up, I just want to remind everyone on the webinar that the registration deadline is October 22nd, with submissions due October 29th. Please stay tuned in terms of the HEF website for other announcements, and always the Fuel Cell Technologies Office news alerts in terms of upcoming webinars and information on the H-Prize. With that, I'd like to thank our speakers and thank Chris for organizing the webinar. And one last time, just a reminder to continue to submit questions regarding safety, any data collection issues, or general questions to the hprize@ee.doe.gov. Thank you all very much.
Great, thanks.